Welcome back to Vectoring AI, where we trace the history of artificial intelligence decade by decade. In our last episode, we explored the 2000s, a period when big data, GPUs, and large datasets transformed AI from a field struggling after winters into one poised for resurgence. The stage was set for the 2010s, a decade in which artificial intelligence moved from research labs into the center of industry, culture, and public life. This was the era of deep learning dominance, spectacular breakthroughs in games and language, and the first large-scale debates over AI's role in society.
Let's begin with the early years of the decade. Between 2010 and 2012, researchers began to achieve remarkable results with deep neural networks. In 2010 and 2011, a deep neural net achieved best accuracy in the German traffic sign recognition competition, a signal that these methods were about to surpass traditional machine learning. Then, in 2011, IBM's Watson made headlines by defeating Jeopardy champions Ken Jennings and Brad Rutter. Watson combined natural language processing, probabilistic reasoning, and ensemble methods to answer questions in real time. For the public, it was a moment as dramatic as Deep Blue's chess victory in the 1990s, proof that machines could now challenge humans in knowledge and language. That same year, Apple released Siri on the iPhone 4S, bringing AI-powered personal assistants into the mainstream.
But the real turning point came in 2012. Geoffrey Hinton's student Alex Krzyzewski built a deep convolutional neural network called AlexNet, trained on the massive ImageNet dataset. With 8 layers and 60 million parameters, it achieved a 16% error rate, 10 points better than the nearest competitor. The model used GPUs for acceleration and introduced dropout regularization to prevent overfitting. AlexNet's dramatic success sparked a global shift. Deep convolutional networks rapidly became the standard approach for computer vision, launching the deep learning revolution.
From 2013 to 2015, progress accelerated rapidly. In 2013, Thomas Mikolov introduced Word2Vec, a method for learning word embeddings that captured semantic relationships. For example, that king minus man plus woman produces a vector close to queen. The same year, DeepMind unveiled the DeepQ network, which learned to play Atari 2,600 games directly from pixels, reaching superhuman performance in titles like Breakout and Enduro. The results, published in Nature in 2015, were a landmark in deep reinforcement learning.
At the same time, new architectures were transforming generative AI. In 2014, Ian Goodfellow introduced generative adversarial networks, or GANs, a system of 2 neural networks competing against each other, one generating images and the other judging them. GANs produced strikingly realistic images and later fueled the rise of deepfakes. That same year, Facebook announced DeepFace, a large-scale deep learning system for face recognition with near-human accuracy. Also in 2014, Amazon launched Alexa, a voice assistant that brought AI into living rooms around the world.
By 2015, deep learning had conquered new milestones. Google researchers introduced the sequence-to-sequence model, which replaced phrase-based approaches in machine translation. Microsoft unveiled ResNet, a network with over 150 layers that used residual connections to achieve record-breaking performance on ImageNet. Google also released Deep Dream, a visualization technique that produced surreal, dreamlike images and introduced the public to AI art.
The years 2016 and 2017 brought breakthroughs that captured global attention. In 2016, DeepMind's AlphaGo defeated Lee Sedol, one of the world's top Go players, in a 5-game match. Go had long been considered beyond AI's reach because of its vast complexity, yet AlphaGo combined deep reinforcement learning with Monte Carlo tree search to achieve a stunning victory. The Netflix documentary on AlphaGo brought this achievement to millions of viewers. Just a year later, DeepMind released AlphaGo Zero, which learned entirely from self-play and defeated the original AlphaGo 100 games to 0. Soon after, AlphaZero generalized the same approach to master Go, chess, and shogi. At the same time, another breakthrough was quietly reshaping the field. In 2017, the transformer architecture was introduced in the paper, "Attention is all you need." By replacing recurrence with self-attention, transformers allowed massive parallelization and became the foundation for all modern large language models.
From 2018 to 2019, scaling became the central theme. In 2018, Google released BERT, a transformer-based model pre-trained on large corpora, which achieved state-of-the-art results on tasks such as question answering and sentiment analysis. The same year, creative applications of AI flourished. Neural style transfer enabled artistic reinterpretations of photographs, while DeepArt and similar projects popularized AI-generated visuals. Waymo, Google's self-driving car spin-off, logged millions of miles on public roads, moving toward early deployment.
Meanwhile, large language models began to appear. In 2018, OpenAI introduced GPT-1 with 117 million parameters, demonstrating the viability of large-scale pre-training. In 2019, GPT-2 expanded to 1.5 billion parameters and generated coherent, diverse text, impressive enough that OpenAI initially withheld the model due to concerns about misuse. That same year, DeepMind's AlphaStar reached Grandmaster level in the complex strategy game StarCraft II, handling real-time play and incomplete information. Facebook's Fair Group launched large-scale machine translation for billions of posts, while NeurIPS, the leading AI conference, saw attendance soar past 13,000 participants, a symbol of AI's explosive growth.
The decade culminated in 2020 with the release of GPT-3. At 175 billion parameters and trained on hundreds of billions of words, GPT-3 demonstrated few-shot learning, generating fluent text, writing code, summarizing documents, and even answering questions without task-specific training. GPT-3 captured worldwide attention and marked a turning point in natural language processing. That same year, Waymo launched Waymo One, the first fully driverless taxi service in Phoenix, Arizona. Generative AI also reached new cultural prominence, with websites like This Person Does Not Exist, producing photorealistic synthetic faces. But alongside the excitement came serious ethical debates. Issues of bias, fairness, accountability, and transparency rose to the forefront. The black box nature of deep models, the potential misuse of deepfakes, and safety-critical failures like the Uber self-driving crash in 2018 underscored the risks of powerful AI systems.
Looking across the 2010s, several themes stand out. Deep learning established its dominance powered by convolutional networks, recurrent networks, transformers, and GANs. Reinforcement learning produced spectacular achievements in games, from Atari to AlphaGo to AlphaStar. Language models grew from word embeddings to massive pre-trained transformers, culminating in GPT-3. Consumer AI became mainstream, with assistants like Siri and Alexa, personalized recommender systems, and self-driving projects. Generative AI expanded the creative frontier, while industry investments surged through labs like Google Brain, DeepMind, Facebook AI Research, and OpenAI. Finally, society began grappling with the ethical dimensions of AI, the need for fairness, transparency, and safety.
By 2020, AI was no longer just a scientific pursuit. It was a central technology shaping business, culture, and everyday life, and raising profound questions about the future.
In our next episode, we'll step into the 2020s, a decade where artificial intelligence accelerates at an unprecedented pace. Large language models are scaling to new heights, intelligent chatbots are becoming part of daily life, and AI agents are beginning to act on our behalf in powerful new ways. The story of AI is no longer just about algorithms. It's about how these systems transform the way we work, create, and connect. Thanks for tuning in to Vectoring AI. If you enjoyed this episode, don't forget to like, subscribe, and share the channel. Stay with us as we continue exploring the unfolding journey of artificial intelligence.